Welcome to Super Easy Physics and Mathematics, SEPAM. Are you ready to conquer the Igcse Physics Paper 4 Extended? In this video, we're diving headfirst into the 2023 October/November Variant 2 exam. I'm Mr. Matthew Orisheje, and I'll be guiding you through questions 1 to 6 with detailed step-by-step explanations. Whether you're aiming for top grades or just need a little extra help, this video is for you. So grab your pen, paper, and calculator, and let's get started. This paper is for 1 hour 15 minutes. You are expected to answer all the 10 questions for the total of 80 marks. Take the weight of 1 kg to be 9.8 Newton, acceleration of free fall equal to 9.8 meter per second square. Part 1 of this solution will treat questions 1 to 6. Part 2 video will treat questions 7 to 10. To support this channel, subscribe, like and share the video. Question 1. A car accelerates uniformly in a straight line from rest at time t equal to 0. At t equal to 3.2 seconds, the speed of the car is 13 meter per second. Question 1a. I. Calculate the acceleration of the car. For 2 marks. Acceleration is difference final velocity and initial velocity divided by time taken. Acceleration is 13 minus 0 divided by 3.2 minus 0. Acceleration is 13 divided by 3.2. Which gives 4.0625 meter per second squared. Question 1a. 2. Explain in words what is meant by the term acceleration. For 1 mark. Acceleration is the increase in velocity per unit time. Its unit is meter per second squared. Acceleration is a vector quantity. The car travels at 13 per second from t equal to 3.2 seconds to t equal to 12 seconds. Question 1b. I. Plot the speed time graph for the car from t equal to 0 to t equal to 12 seconds. For 2 marks. From the origin, 0, 0, draw a slant straight blue line to the point A, with coordinates, 3.2, 13. This line represents acceleration from rest to the final velocity of 13 per second. The slope of this line is the acceleration of the car. From point A, draw a green straight horizontal line to the point B with coordinates, 12, 13. This green line is parallel to the time axis. This green horizontal line implies the car moved with constant velocity the time 3.2 seconds to 12 seconds. For drawing the blue line correctly you get 1 mark. You will obtain the second mark from drawing the green line correctly. Question 1b. 2. Determine the distance traveled by the car between t equal to 0 and t equal to 3.2 seconds. For 2 marks. In velocity time graph, distance traveled is obtained by calculating the area of the shape under the curve. The distance required in this question is the area of the yellow triangle under the blue line. Base of triangle is 3.2 seconds. Height of triangle is 13 meter per second. Distance is equal to product of 3.2 and 13 divided by 3. Distance is equal to half of 41.6. Distance is equal to 20.8 meter. Question 1c. The car decelerates from 13 meter per second to 0 meter per second at a constant deceleration. The mass of the car is 1,350 kg. The car travels 13 meter in 2 seconds as it decelerates. Show that the work done by the car as it decelerates is approximately 1.1 times 10 raised to power 5 joules. For 4 marks. Work done is equal to braking force multiplied by distance traveled by car. Work done is equal to mass of car multiply acceleration times distance. Work done is equal to 1,350 multiply 13 minus 0, divided by 2 times 13. Work done is equal to 1350 multiply 6.5 times 13. Work done is equal to 8775 Newton multiply 13 meter. Work done is equal to 1 and 14,075 joules. Work done is equal to 1.1 times 10 raised to power 5 joules. Question 1d. On another day, the car in C travels a longer distance while it decelerates from 13 meter per second to 0 meter per second. The deceleration is constant. Suggest and explain what causes the stopping distance to increase. Given that the deceleration and initial velocity of the car remain constant, the following three factors can increase the stopping distance. Number 1, increased road gradient, uphill slope. Explanation: driving uphill increases the stopping distance because the car's gravitational potential energy increases, requiring more energy, and thus a longer distance, to bring it to a stop. Additionally, the engine's braking effect, engine braking, is reduced uphill, relying more heavily on the friction brakes. Number 2, road conditions. Explanation: even with constant deceleration, the effectiveness of brakes can vary based on road conditions. For example, wet or icy roads reduce tire traction, which in turn reduces the braking force. This extended braking distance leads to an increased stopping distance. Number 3, tire condition. Explanation: the condition of the tires significantly impacts stopping distance. Worn-out tires have reduced grip, affecting the car's ability to decelerate effectively. This decreased braking performance results in a longer stopping distance. The total marks for question 1 is 13 marks. Question 2. Figure 2.1 shows an electric tumble dryer used to dry wet clothes. Question 2a. Hot air blows into the drum. The air gains water vapor from the clothes and then leaves the drum. The moist air enters the condenser. Cool air leaves the condenser, passes through the heating element and enters the drum again. I. State the process by which the hot air removes water from the wet clothes. Evaporation is the process by which the hot air removes water from the wet clothes. 2. The air is cooled as it passes through the condenser. Describe and explain one other way in which the air leaving the condenser is different from the air entering the condenser. Description: the air leaving the condenser contains less water vapor. Air is drier. Explanation: the condenser cools the moist air coming from the drum. As the air cools, its ability to hold water vapor decreases. This causes the water vapor to condense into liquid water, which is typically collected and removed from the condenser. Therefore, the air leaving the condenser has a lower humidity level, less water vapor, compared to the air entering it. Question 2b. The drum of the tumble dryer rotates, lifting up the wet clothes which then fall down through the hot air. I. Name the force that causes the clothes to fall down. Gravitational force or weight is the force that causes the clothes to fall down. 2. When the drum rotates too fast, the clothes remain in contact with the wall of the drum. State the direction of the resultant force on the clothes during the circular motion. The direction of the resultant force on the clothes during circular motion is towards the center of the drum. The force is perpendicular to the motion of the clothes. Question 2c. Suggest why using a clothesline to dry clothes in the open air is better for the environment than using an electric tumble dryer. Using a clothesline to dry clothes is better for the environment than using an electric tumble dryer, primarily because it conserves energy. Let's consider some of the benefits of using clothesline. 1. Reduced energy consumption. Tumble dryers require significant electricity to operate, contributing to greenhouse gas emissions. Clotheslines harness the sun's free energy, eliminating this energy consumption. 2. Lower carbon footprint. By reducing electricity usage, clotheslines help decrease your carbon footprint and mitigate climate change. 3. Reduced reliance on fossil fuels. the electricity used to power tumble dryers often comes from power plants that burn fossil fuels, releasing harmful pollutants into the atmosphere. Clotheslines bypass this process. The total marks for question 2 is 6. Question 3. 3a. A balloon of mass 15 gram is glued to a straw. The straw is threaded onto a horizontal string, as shown in figure 3.1. The balloon is filled with air and then the air is released. As the air leaves the balloon experiences a force. The balloon accelerates from rest until it reaches a constant speed. It then travels 0.67 m in 0.18 seconds at this constant speed. Explain in words what is meant by the term impulse. Impulse is the product of force and time for which force acts. Impulse is the change in momentum. 2. Calculate the resultant impulse on the balloon while it is accelerating. Impulse is equal to mass of balloon multiply change in velocity. Impulse is 15 over 1000 kg multiply 0.67 divided by 0.18. Impulse is 0.0558 Newton-second. 3. Explain how momentum is conserved as the balloon accelerates. Momentum is conserved as air released from the balloon moves in the opposite direction to the balloon. Momentum of balloon and straw is equal in size to momentum of air released from the balloon. 3b. Figure 3.2 shows the directions of two forces acting on a different balloon as it moves. Determine the magnitude and direction of the resultant force on the balloon. There are two methods you can use to get the resultant force on the balloon. Method 1 is using scale drawing. Method 2 is using Pythagorean theorem. Let's use the second method. The blue line is the force of propulsion acting towards the right on the balloon due to the rate of release of air from the balloon. While the green line represents the weight of the balloon acting downward. The vector addition of these two forces gives the red line acting along southeast to the blue force with direction given by angle theta. Applying Pythagoras' theorem, the square of A plus the square of B gives the square of C. Relating it to this diagram. The square of red resultant force is equal to the square of blue force plus the square of green weight. The resultant force is the square root of 0.7076, which is 0.84 Newton. The next step is calculating the direction of the resultant force using trigonometric ratio. The direction of the force theta is equal to arc tan 0.74 divided by 0.40. The direction of the force theta is equal to 62 degrees to the horizontal propelling force. Question 4. Figure 4.1 shows a bottle part filled with water. The air inside the bottle is at the same pressure as the air outside the bottle. The bottle and its contents are at room temperature. For A, the temperature of the bottle and its contents are increased. Explain, in terms of particles, how the air pressure inside the bottle changes as the temperature increases. There are 5 possible sequential points to this explanation. Fact number 1, as temperature of water in the bottle increases, the average speed of air particles in the bottle increases. Fact number 2, the increase in speed makes the particles to collide with the wall of bottle more frequently. Fact number 3, the frequent particle collision leads to high force per unit area exerted on the wall of bottle. Fact number 4, the more forceful particle collision leads to high pressure exerted on the wall of bottle. Fact number 5, since the volume of the bottle remains constant, increase in temperature leads to increase in pressure inside the bottle. 2. The lid is removed from the bottle. State and explain how the air pressure inside the bottle changes. Statement: pressure in the bottle decreases. Explanation: as air particles escape from the bottle into the air, the number of particles colliding with the wall of the bottle reduces until pressure inside the bottle is same as atmospheric pressure. Question 4b. The mass of water in the bottle is 0.18 kg. The specific heat capacity of water is 4,200 joules per kilogram degree Celsius. Calculate the thermal energy needed to increase the temperature of the water by 20 degrees Celsius. Thermal energy is equal to product of mass of water, specific heat capacity of water and temperature rise. Energy is equal to 0.18 times 4,200 times 20. Thermal energy is equal to 15,120 joules. Thermal energy approximately 15,000 joules to two significant figures. For C, another plastic bottle is filled to the top with water. The height of the bottle is 40 cm. The density of water is 1,000 kg per cubic meter. Calculate the pressure difference between the top and bottom of the water. Pressure under water is equal to the product of density, acceleration and depth of water. Pressure difference is equal to density of water multiply acceleration due gravity multiply height of water. Pressure difference is 1000 times 9.8 times, 40 over 100. Pressure difference is 3,920 Pascal. Question 4 has the total of 9 marks. Question 5 Figure 5.1 shows a road junction, a moving car and a stationary truck. The road has high walls on each side. A. The driver of the truck is at position X. The car moves around the corner. On Figure 5.1, label a point Y on the road where the truck driver first sees the car. The driver of the truck is at position X will see the car as soon the car crosses the red line of his sight directed to the left-hand side of the junction. Question 5b. A plane mirror is placed at the road junction as shown in Figure 5.2. Show how this mirror allows the driver of the truck to see the car when it is at the position shown in Figure 5.2. The incident ray from the car tangential to the high wall strikes the mirror and is reflected to the eye of the driver X in the truck. Question 5c. The truck driver wears spectacles to correct long-sightedness. Figure 5.3 shows how a blurred image of an object O forms on the retina. Any effect of the cornea on the rays of light can be ignored. On Figure 5.4, show how long-sightedness is corrected by adding a suitable lens in front of the eye, continuing the path of the three rays of light until they meet to form an image. Long-sightedness happens when light focuses behind the retina. This makes nearby things blurry. A convex lens is like a magnifying glass. It makes things look bigger by bending light inwards. When the driver wears convex glasses, the lens bends the light coming into his eye a little extra. This helps the light focus exactly on his retina. So, he can see nearby things clearly again. The total marks for question 5 is 7. Question 6 Figure 6.1 shows the circuit diagram for a flashlight, torch. The electromotive force of the battery is 4.5 volts. The circuit contains a 60 ohms fixed resistor. The current in the light-emitting diode is 0.02 amperes. Question 6a. Calculate the potential difference across the light-emitting diode. The electromotive force of the battery is equal to the potential difference across the light-emitting diode plus potential difference across the resistor. The potential difference across the light-emitting diode is equal to the electromotive force of the battery minus the potential difference across the resistor. The potential difference across the resistor is equal to product of the current flowing across the resistor and the resistance of the resistor. The potential difference across the resistor is equal to 0.02 amperes multiply 60 ohms. The potential difference across the resistor is equal to 1.2 volts. Therefore the potential difference across the light-emitting diode is equal to 4.5 volts minus 1.2 volts to give 3.3 volts. Question 6b. Explain why the LED does not light up if the battery is reversed. Light-emitting diode only allows current in one direction. Light-emitting diode has a very high resistance when direction of current is reversed. Light-emitting diode has high resistance when it is reverse biased. Question 6c. The chemical energy stored in the battery is 1050 joules. Show that the flashlight operates for approximately 3 hours. Energy stored in the battery is equal to the product of voltage across battery, current flowing across battery and time taken for current to flow in seconds. Energy is equal V I T. 1050 joules is equal to 4.5 volts multiply 0.02 amperes multiply times in seconds. Times in seconds is 1050 joules divided by 0.09 to give 11,666.67 seconds. Converting time of operation to hours is 11,666.67 seconds divided by 3,600 seconds per hour, which gives 3.24 hours. Question 6d. Calculate the total charge that flows through the LED in 3600 S. Quantity of charge is equal to product of time and current in diode. Quantity of charge is 0.02 amperes multiplied 3600 seconds. Quantity of charge is 72 coulombs. Total score for question 6 is 7. And there you have it, a detailed breakdown of questions 1 to 6 of the Igcse Physics Paper 4 Extended 2023 October/November Variant 2 exam. Remember, practice makes perfect, so re-watch this video as many times as needed to solidify your understanding. Don't forget to subscribe to SEPAM for the second part of this solution covering questions 7 to 10. Hit that notification bell to stay updated on our latest uploads. Like, comment, and share this video with your friends if you found it helpful. Your support motivates us to create more valuable content. See you in the next video.